Welcome back to our channel. So in the previous session we have seen the introduction to C++ as well as the difference between the C++ and C. So in today's session we will go with the one more concept that is called data types available in C++. So already in C language we have seen that several data types available in C. So the same thing will be repeated in C++. Addition to that, only one variable, only one data type is available. So we'll see that data types. See, coming to the data types, the name itself indicates data type. So by using these data types, we have to declare a variable such that that variable should contain only such type of data. So for example, integers, all the integers, that means the numbers without any fractional values, will be declared as keyword int. So all these are the keywords. With the help of keyword we have to declare a variable. So these are the data types. And coming to the float, float means with a fractional value. The data type is float. Example 1, 2, 3, etc. Example 3.14, 4.5, etc. Double. Here double is also the similar thing, but the difference between the double and float is a precision. Precision means after the decimal, the number of decimal points. The number of decimal points is a precision, right? So it will be having less precision and double will be having the more precision. Characters. So for all the characters, we'll use a char. So these are the keywords. All these are the keywords. With the help of keywords, we have to declare the variable. So characters means every key in the keyboard will be considered as a character. That means it may have some small a to small z, capital A to capital Z, 0 to 9, and all the symbols. Everything will be considered as a character. And there is one more data type available in C++, which is not in C, is a Boolean data type. Boolean, B-O-O-L. So this is nothing but 0 or 1. So 0 represents the false, 1 represents the true. So these are the fundamental data types. All these are the data types. Integer, float, double, character and Boolean. See, all these are keywords. Right? So we have to declare the variable based upon the type of data which we are going to store in that variable. If you want to store only the natural numbers without any fractional part, those variables should be declared as integer. If you need to store any characters or symbols, we have to declare that as a character. Right? Next, apart from these data types, so everything will be having a range. So apart from these data types, there are also called modifiers. So for every data type there will be a limited range of values. Okay. So in order to use the range out of the given range, use the values which are out of the given range, then we have to go with the modifiers. Modifiers, the name itself indicates, it modifies the range of the data types. See, here we are having a modifiers. So one is short, long, and these are the range modifiers. These are the sign modifiers. So here unsigned means it will accept only positive numbers, only positive values. Right? Unsigned means it will accept only positive values. If it is signed, it will accept both positive and negative values. For everything, there will be both the signed and unsigned. So short and long. Short means the range will be less, long means the range will be more. So already the range of existing range of the data type will be modified. Okay. If you take integer, it will be having shortened, longed. So actually the integer will occupy 4 bytes of memory, whereas the shortened will occupy only 2 bytes of memory and longed will occupy 8 bytes of memory. Right? So here, how to find the range? So first we have to know how many bytes of data the variable will be occupied. So if you declared int a, that means a will occupy some 4 bytes of memory. So in the memory, some 4 bytes of data will be stored for a variable a. So that happens for this statement. So first we have to know the size of the data type so that we can know the range of values which can accept by that particular variable. So simply we can say first we have to convert it into bits. So that is nothing but 32 bits, right? 32 bits. Okay. So int will have 32 bits or 4 bytes. Is it clear? Now we have to find the range of values that integer will accept. That is, the range of int is nothing but minus 2 power 32 minus 1 to 2 power 32 minus 1. Right? So this is the only thing we can have to find the range of particular data types. So first we can convert the bytes into bits and then we can have the range. And if it is a unsigned int, the values will be starting from 0 to 2 power 32 minus 1 because it will accept only the positive values. So we have to write this one. If it is unsigned, 0 to 2 power the size of data type minus 1, and if it is a signed, it is nothing but minus 2 power size minus 1 to 2 power size minus 1. But in terms of bits, we have to calculate in terms of bits. So this is how we can find the range of any data type. Okay. So we can write it generalized. Range is equal to 2 power n minus 1 to 2 power n minus 1. Minus 2 power n minus 1 to 2 power n minus 1. Where n is size of a data type in bits. That's very, very important. And how to find the size of any data type? So similar to our C language, here also we have the Sizeof operator. Sizeof operator. So with the help of Sizeof operator, we can have the size of that particular data type. So this function, this operator will return an integer tells the size of that particular data type. So we can pass one argument for the size of that argument can be either the data type or the variable, right? So these are called the modifiers, right? And data types are integer, float, character, double and boolean. So by using the compiler, by using the sizeof operator, we'll know the size of each and every data type along with the modifiers. So we'll go with the integer, signed int, unsigned int, short int, signed unshort int, signed short int, unsigned short int, and long int, signed long int, signed unsigned long int, float, double, character, unsigned character, signed character, boolean. So we'll see the size of all these data types along with the modifiers in a program, executing in a program, right? I will show you that. Now, one more thing I just want to know, let you know that in the program we will use a namespace in C programming. That's important. So in C++, we'll use this namespace which is not available in C. This is an additional feature added in C++. So what is the use of namespace? So I am elaborating this because we are going to execute a program where we use this namespace, right? So this namespace means this is used to avoid the naming collisions. Naming collisions. So naming collisions means here, for example, there are two persons with the names some ABC, here also some ABC. Okay, so how can you call these two persons? If you call like ABC, right? So who will respond you? So there must be some additional feature to differentiate these two persons, so that we'll use some initial, some k.abc, some b.abc. So we can call like a.abc. If you call k.abc, this person will respond. If you call b.abc, this person will respond. Or with the help of roll number, for example this 10, for example this 12. So with the help of roll number, this person will be communicated, and with the help of 12, this person will be communicated. So this additional thing to represent the name is called this namespace. So hope you understood. So namespace is used to store the identifiers to avoid the collisions. So all the identifiers will be stored in the namespace. Okay, so there is a standard namespace where all the predefined words will be available in that namespace. With the help of namespace, we have to access the identifiers. See, one more example. So let us take a class, two classes. Inside this class, we had a function. Right? Inside this class, we are also having one more function with the same name. So this is possible. But if you access in the main, see, the main function can access both the class 1 and class 2. Okay, so if you go in depth, you can understand, right? So a class can have the variables and functions. Similarly, here also we are creating one more class with the function. Now, in the main function, I can use both the class 1 and class 2. So, in the main function, if I call this function, which function will be executed? whether this function is executed or this function is executed, because both the functions are having the same name, right? So I want to access this function, class 1 function. So I am just calling this function. So which function will be executed? So such type of situation we call it as naming collision, because two functions are having the same name. So we are having, the compiler doesn't know which is to be executed. For this purpose, we have to give some additional information for getting the perfect function. So if you want to access this class 1 function name, the function which is under class 1, we have to call this function as class 1 column. See, class 1 2 columns function. So this is called scope resolution operator. Scope resolution operator. Scope resolution operator. Right? So with the help of this one, we can access the function. So in order to avoid all these things, we can use this namespace as a global namespace, so that we can use the identifiers which are available in that namespace directly in our program. So I will show you that in our program, right? So in our program, we are going to use this namespace in order to avoid the naming collisions, and there is a standard namespace. So the syntax is the using namespace std. Std is nothing but our standard namespace. So where we can use the cin and cout. This is the for input function. This is the output function. Just like our scanf and printf, right? And we are going to use the IO stream. So IO stream is also inherited from the stdio.h, right? So all these functions will be available in this IO stream. So during the linking section, these output functions will be linked with the header files. Okay, so namespace for avoiding the naming collisions, so that we can use directly cin and cout, and IO stream is a similar to our stdio.h. So with the help of all these things, and Sizeof is used to get the size of a particular data type, right? So with the help of all these things, we'll execute a program, so getting the size of all the data types along with the modifiers, right? So hope you understood this session. So we'll go back with the compiler and I will execute the program so that your doubts will be clarified, right? So move to the program.
Hello friends, so just now we have seen the different data types available in C++. Now, and also the modifiers we have seen, and now in this session we'll see the size of each and every data type, including the modifiers, right? So first we have to include the IO stream. So I am using the online compiler, and then we have to use the namespace. So as we have discussed, that namespace is used to avoid the naming collisions, right? So to avoid the naming collisions, we use this std, namespace, and now we'll write the main function. So the every program will start its execution from main function. So here I am writing. So what is here, the input and output statements are cin and cout, right? So cout is for output statement. So cout excuse me, here we have to give the size of, or we can write the text. So integer is equal to, and write down the variable here. So in the variable section we can write the size of operator. So we know that size of operator will give the size of that particular data type. So int is the keyword for integer, so that one, and we have to end that line by using end l, right? If you are not using end l, the next one will be also printing in the same line, just like our /n operator. So /n we are using in C for printing the text in next line, a new line. So similarly here we call it as a end L, end line. So here if we are keeping the end L, so next cout function prints the text in the next line. So cout, and we'll go with the modifiers. So unsigned integer is equal to, similarly, size of unsigned int, and again end L, right? Next, cout signed integer is equal to size of signed int, and last we have to write ndl. See, just we'll see the execution. So here every statement should end with semicolon. Semicolon is the termination of that particular statement. Now if you run this one, see, we can observe the integer, the size of an integer is 4 bytes, and unsigned integer is also a 4 bytes, and a signed integer is also a 4 bytes, right? Now let us check with a few more modifiers, that is a short int. Short int is equal to, and again size of short integer, and here you can write and L. Similarly, cout unsigned short int is equal to size of unsigned short int. So I have to write the data type here. So ndl, and next one more thing, signed short int is equal to size of signed short int, again ndl. Now we'll see, if you execute this one, we'll get the size of short int. Sorry, I forget to keep the semicolon, because semicolon is the termination, right? Now if you run this code, you can get the size of all those things. So short int 2, unsigned short int 2, and signed short int also 2. So here you can observe the remaining. So integer 4, unsigned integer 4, okay, signed integer 4, short int, unsigned short int, and signed short int. Now we'll go with one more thing, long int. Long int size of long int and L. Next cout, similarly unsigned long int size of unsigned long int and L. Cout signed long int size of signed long int and L. Right, now let us observe that code. Sorry, somewhere we have given a single less than symbol. Yes, right, now you can observe. Yes, so here you can observe the long int is 8 bytes and the size of unsigned long int is also 8 bytes and signed long int also 8 bytes. So for it is a normal integer, whether it can be either unsigned integer or a signed integer, the size is 4 bytes, and a short integer, either it may be unsigned or a signed. For the short integer it will be the 2 bytes, and for the long int either it may be assigned or unsigned, the size will be in 8 bits, 8 bytes. Now, so everything is in terms of bytes, not bits. So if I said bits, that's just a correction. It's completely in terms of bytes. Right. Now let us check one more thing, that is character size of char and L cout unsigned character size of unsigned char and L cout signed character size of signed char and L. See, if you observe here, see, character either it may be signed or unsigned, the size is 1 byte. Next, similarly, cout float is equal to size of float and L. Similarly, we'll go with the double also. Double is equal to size of double, and also we will see the long double also. Long double, and also we'll go with the one more data type called Boolean. So here we are having one more data type, it's called a Boolean. Boolean, that is either true or false. So size of bool, the keyword is bool, and L. Right. Now if you run this code, we'll get the complete. Right. Yes. So if you observe this one, See, for integer it's a 4, and for the character it's 1. Up to there we have covered, and now we have written the float. So for float the size is 4 bytes, for double the size is 8 bytes, for long double it is a 16 bytes, and the boolean is only 1 byte, similar to the character, right? So these are the size of all the data types, including the modifiers, right? So this is the thing we have covered in today's session. We'll stop it here, and if you are having any doubts regarding this session, feel free to post your doubts in the comment section, so that I will definitely try to clarify all your doubts. And if you really understood my session, like my session, share my session with your friends, and don't forget to subscribe to our channel. Thanks for watching. Thank you very much.